Okay, welcome back. We are in chapter 7 now, starting chapter 7, and we're looking at section 7.1, which is the law of sines. So, chapter 7 a little bit better because it is applying trigonometric applications to maybe just a little bit more real life situations that might make a little more sense. So, just a reminder there is a new formula sheet for chapter 7. So make sure you have downloaded that from WebAssign and printed it out. And one of the things I want to emphasize for chapter 7 especially is you need to, for each problem, have a diagram. So if there is not a diagram given, which normally is just a triangle, then you need to sketch a diagram and label it so that you can make sure you're relating the right measures, whether it's an angle measure or a side measure, in the right order, in the right place, and all of that. So the law of sines allows us to find measurements in what are called oblique triangles. So trigonometry is based on the math of right triangles. Oblique triangles are triangles that do not have a right angle. However, we can use the law of sines to find measures within those triangles. Okay, so first off, the first two we're going to look at are when we're given either two angles and a side or two sides and an angle. So notice the two angles, the side is not between the two angles and the single angle is not between the two sides. So that's important to know when you have your triangles. So I'm not going to go through all the details of how to derive the formula, which is shown here on this page. But you can see our blue triangle here is not a right triangle. However, we've drawn this height or altitude in here, which creates two smaller right triangles, because this would be a right angle right here. So from that, we can get these two equations, which aren't so important now, but will be a little bit important later. So the height can be equal to A times the sine of B or B times the sine of A, either one. We're going to have to find the height a little bit later in some of these problems, so that's important. But what we will be using right now is just the law of sines. So here's the law of sines down here at the bottom. You have that in your notes. It basically says that the ratio of the side over the sine of the related angle, we'll say, is equal to the side over the sine of the other related angle, which is equal to the side over the sine of the other related angle. So just remember, in these triangles, the corresponding, that's the word I should have used instead of related, corresponding angle is opposite the side. So side A is opposite angle A, side C is opposite angle C, side B is opposite angle B, okay? And also remember that the shortest side will be opposite the smallest angle, the longest side will be opposite the largest angle. So keep that in mind as you're working on these so that you can make sure you have it labeled correctly and make sure your answers make sense. So we can use any portion of this. So if I just needed to use the first two, I could use that ratio and solve it. If I needed to use the first one and the last one, I could use that ratio and solve it, or any combination for those. So what we're looking to do here is find the missing sides or the missing angle measures in a triangle. Okay, so they're going to ask you to solve the triangle. Solve basically means find all the missing sides. You can see that here in your notes. You got that right here. Solve means find all the missing angle and side measures. So here's our first example. We got triangle ABC. So first off, I'm going to draw that. Again, the way the triangle looks isn't too important because we're not looking for exact diagrams. We're just looking for a sketch. And so we could have, this would be angle A, this could be angle B, and this could be angle C. Again, those are capital letters. This would be side A, this would be side B, this would be side C. in lowercase. So they tell us angle B is 36 degrees. Let's label that. And angle C is 87 degrees. And side A is 10 feet. So there's all the information we know so far about our triangle. And we can use the law of sines to find the other angle measures or the other side measures. Now the angle is kind of easy. When we got two angles, we can easily find the third angle just by adding them together. Because remember, any triangle, the total angle measure adds up to 180 degrees. That is for every single triangle. So if we have that, we can subtract the 36, we can subtract the 87, and if we do that, we should get 57 degrees, which is equal to angle A. So the angle is pretty easy. When we have two of them, we can easily find the third one, okay? So for side B and side C, we're going to use the law of sines. So let me fill that in here. So we've got A over the sine of A equals B over the sine of B. So we can fill in the information we know. A is 10. The sine of A would be the sine of 57. B we don't know. We're going to try and find that. And the sine of B would be the sine of 36. So when you're solving this, you're going to use cross multiplication. So we're going to multiply the two values that we know that are opposite each other, and then divide by the other value that we know. So this is a proportion. We're basically solving proportions. Proportions you can solve using cross multiplication, and then come up with your solution. So basically, B in this case is equal to 10 times the sine of 36 divided by the sine of 57. And if we work that out, we get 7 feet. Okay? So as always with these, let me just remind you, read the question carefully, pay attention to what amount or what number of decimal places the question is telling you to round to. If it doesn't tell you to round to anything, then 1 decimal place is fine. Okay? All right, so we're going to use that same formula, except now we're looking for C. So we're going to have 8 over the sine of A equals C over the sine of C. And if we plug in everything we know again, we'd have 10 over the sine of 57 equals C over the sine of 87. So we can go ahead and solve for C. C would equal 10 times the sine of 87. Again, you're going to cross multiply and divide by the sine of 57. And if you work that out with your calculator, you're going to get 11.9 feet. So we've got angle A, 57 degrees. We've got side B, 7 feet. We got side C, 11.9 feet. So we've solved our triangle. We've found all the side measures and all the angle measures. So that's the basic use of the law of sines. Now, there are some exceptions, which you have on this page 2 of your notes. And these are called ambiguous cases. So when we have two sides and an angle, if the angle we're given is acute, we need to make sure that we actually have a triangle, and we need to make sure that we don't have two different possibilities. So there's where the ambiguous parts come in. We may have one triangle, we might have two triangles, or there may be no triangles at all. And what determines that is the height. So if we have side-sided angle, and A, or the angle we're given, is acute, it could be angle B, it could be angle C, they're just using A in this example, then we need to check. And what we're checking is we're checking the height. So I told you we were going to use one of the formulas that was back on the first page. This is when we will use it. So the height needs to be either equal to one of the sides or it needs to be less than both sides. So if you think about a triangle, here's my triangle here, or here's what could possibly be a triangle, okay? If my height, let's do that in blue, if my height is too long, so here's my height, then my other side, coming down here, I should make that red, isn't going to connect. So this doesn't form a triangle. So if our height is larger than any one of the three sides, we do not have a triangle. If our height is equal to one of the sides, then the height is actually one of the sides, which means we have a right triangle. And if the height is less than both sides, then there are two possible triangles. One with acute angles and one with obtuse angles. So that's one thing you need to check. Now, if the angle is an obtuse angle, we need to make sure that the opposite side is less than the other side we're given. Otherwise, there is no triangle. Okay? All right. And basically, if we do have an obtuse angle, here's the kicker with this. Chances are there is no triangle, because if you think about it, the obtuse angle, that's going to be the largest angle in the triangle, is opposite the longest side, so that side is going to be larger than any other side, so we would have no triangle. So unless the obtuse angle is equal to another side, which is pretty much unlikely as well. So let's look at an example with that. This example is going to look at case number 1. So here's our triangle, given a triangle ABC. B is 23, A is 8, and side B is 6. And they want to know, find angle A. So we're not solving the whole triangle here. We're only finding angle A. So the first thing we need to do is we need to check the height. So H is equal to B times the sine of A. Again, that formula is on your first page. So B is 6. The sine of A would be the sine of, B in this case. Well, let's change this to match up what we got. So since we have angle B, we want A times the sine of B. Sorry about that. So we got 8 times the sine of 23. And if we work that out, then we get that H is 3.13. So 3.13 is less than both of our sides. And if you look back up at number 3, if it is less than both measures, then there are 2 possible triangles. Okay? So let's see how this is going to work. So we need to find angle A. So we can use the law of sines. A over sine of A equals B over sine B. Now remember, we're only looking for the measure of angle A, so we don't have to solve the entire triangle. So let's fill everything in. We know that A is 8. We know that B is 6, and the sine of B would be the sine of 23. So again, we can cross multiply going this way, and then divide by 6. So the sine of A is equal to 8 sine 23, all divided by 6, which, if we round that off, I'm going to use 5 decimal places just so we can get a fairly exact measure. 52097 is the decimal. So we need to find A. So the sine of A is 0.52097. That means A is equal to the inverse sine of 0.52097. And if you work that out, you get 31.4 degrees. Well, remember, we need 2 different angles. So where's the second one going to come from? Well, remember, sine is positive in both the first quadrant and the second quadrant. That should be degrees. So that means not only could it be 31.4 degrees, but it could also be 180 minus 31.4 degrees, or 148.6 degrees. So there are two angles that are possible for angle A, either 31.4 degrees or 148.6 degrees. So anytime you have side-side angle with an acute angle, make sure you check and see if the height is less than or equal to the sides. So, and make sure you find both angles. All right, now, again, we were only finding one angle here. If we were to find the sides, obviously, we could have two different measures depending on the sides. So the measure of side C would be different depending on whether A is 31.4 or whether A is 148.6. So if you're solving the entire triangle, you would get two different answers for angle C. You would get two different answers for side C as well. Okay. All right, so we're going to look at a couple of word problems. So again, I can't stress enough, this is where it's really important to draw a diagram or at least a sketch. So a radio antenna 85 feet high is located on top of an office building. Well, let's start with our office building. So here's our office building. And on top of that, we have a radio antenna. It is 85 feet high. Okay. At a distance AD from the base of the building, so let's say we got this distance here out to some point. We'll call that A, we'll call this D. The angle of elevation to the top of the antenna is 26 degrees. So going up from A to the top, this angle here is 26 degrees. And the angle of elevation to the bottom of the antenna, or basically the top of the building, think of it either way, is 16 degrees. So our angle of elevation here, we'll go to the bottom of the antenna because we'll assume the antenna, let's put the antenna in blue all the way to the bottom. We'll assume that imaginary line goes all the way to the bottom. So we actually have some triangles there. That angle is 16 degrees. So this angle here is 16 degrees. So let's do some simple math first. If the whole thing is 26 and this little part is 16, that means this part in here, this angle is 10 degrees. Okay? And they want to know what's the height of the building. So we're looking for this measure right here. Well, that's the side of this smaller triangle, and it's a right triangle because we're assuming that the building is, you know, at a right angle with the ground. So we got the small right triangle, we got this large right triangle, and we have this funny triangle in the middle, which is an oblique triangle. So I know this is 16 degrees down here. If I knew what this side is here, we'll call that X. I could use that along with this, we'll call this H, for the height of the building. I could use that to find the height of the building with one of my trig ratios, either sine, cosine, or tangent, in this case, sine. So I can use the biggest triangle, the big right triangle. Let's label that a little bit. Let's make this B up here. So I got triangle A, B, D. I can find this angle because the bottom is 90 degrees. So 180 minus 90 minus my angle of elevation was 26. So if I do all of that, that gives me an angle of 64 degrees for B. So in, and let's call this point right here C. So in triangle ABC, I know two angles, 10 and 64, and I know a side. And this would be side, let's see, that's angle A, so this would be side A. And this is angle B, so this would be side B. So the sine of A, well, let's start with the measure of A. The measure of angle of side A over the sine of A, let's see, that would be 10, is equal to the measure of side B over the sine of angle B. So B is equal to 85 sine 64 divided by the sine of 10, which gives us a measure of 439.96 feet. So side B, this long side here from A up to C, is 439.96. So now that I have that, let's label that 439.96. I can solve and find H, because this angle down here is 16. I've got opposite over hypotenuse. So the sine of 16 is equal to H over 439.96. And that means that H is equal to 439.96 times the sine of 16. So my building height is 121.3 feet. So typically most of these problems are going to be just like that, where you have two different triangles. You've got to find one side in one of the triangles, and it'll be a shared side with the other triangle, and then you can find the measure you want in the other triangle. Okay. All right, the last thing we're going to look at is using some angles in two different measurements, which are called headings and bearings. So these are used with either aircraft or with boats, some sort of craft. So the heading is the angular direction that a craft is pointed. So if we're looking at what direction a boat or what direction a plane is traveling, that's the heading is which way it's pointed towards. Okay, so and you can see here it says the heading is expressed in angular measure or angle measured clockwise from north. So here's our compass point. North is up that way. So if we were traveling, let's say this angle is 37 degrees, and we were traveling in that direction, we would be traveling at a heading of 37 degrees. Okay. If we were traveling instead in this direction over here, again, clockwise from north all the way around to here, that might be a heading of, let's say, what would that be? Maybe about 235 degrees. So a heading of 235 degrees. So notice there's no direction with the heading. It's not north or south or west or anything like that. It's just a degree measure. All right, the second one is bearing. Bearing, again, is an angular measure showing direction, but it's used to locate one object in relation to another. Okay, so I may be going at a heading of 40 degrees, but there's a airplane hangar with a bearing of a certain measure. Okay, so I'm comparing the airplane's location to another object's location, and this is expressed in terms of an acute angle formed by either north or south and the line of direction. So let's label this real quick just to make sure we're all on the same page. Going up is north, going down is south, going over here is east, going this way is west. Okay, so we're always going to be north or south some number of degrees. Let's say we're north 15 degrees east. That's how you'll usually see it. Or it might be written as 15 degrees east of north. So that means we're heading in a northern pattern. So we're on this half of our coordinates. And we're east of north 15 degrees. So we're over here, and this angle here is 15 degrees. Okay. Let's say instead we might be going south 30 degrees west. So our bearing would be somewhere over here, and the angle between the south and our direction would be 30 degrees. So we're going to use both of those to solve some problems. And again, I cannot stress enough that you need to draw a diagram. Okay? All right, let's take a look at this. So here's our problem. We have a ship with a heading of 130 degrees. So let's start off. First thing you want to start off with this is drawing your north. If you have a heading, draw your north, put a little N on it up top. And our ship is right here. We're going to call that point A. And it has a heading of 130 degrees. So 130 degrees would be something like right here. And again, from here around to here is 130 degrees. And when it starts off, it sees a lighthouse with a bearing of south 15 degrees west. So from the point we're at here with our ship, let's make this a different color. Over here, 15 degrees west, or 15 degrees west of south, there is a lighthouse. Let me draw a little lighthouse here. Kind of ugly, but there it is. We'll call that point B. And it says after the traveling 10 miles, so the ship is down here somewhere, let's call that point C, and we've gone 10 miles from our starting point to point C. The ship observes a lighthouse at a bearing of north 80 degrees west. Well, north, my ship needs to be a little bit further down, I guess. Let's move it a little further down because it has to look north. So let's call this point C. And then from here, we've got a new bearing. So we need a new north line. And the bearing here going up to the lighthouse is 80 degrees. This whole thing, 80 degrees west of north. And they want us to find the distance from the ship to the lighthouse at the time of the second sighting. So our second sighting is C. So we're looking for, this would be side A of our triangle. We're looking for side A. So first off, we need to find some degree measures because we have a bunch of degree measures here, but they're not all inside the triangle. Okay. So think about this. A straight line, if I go from one all the way around, is 180 degrees. Well, at point A, I'm only going 130 degrees, so the difference to get to my straight line down here would be this angle right here, which is 50 degrees. And I know that this angle over here is 15, so that means angle A is 50 plus 15, which is 65 degrees. Okay? So if that is 65, so here's another thing that we need to know. These two lines here, our first north and our next north, they are parallel. So we have this line. I'm going to draw a much larger line here. We have this line going through these two parallel lines, right about there. Not exact, but you get the idea. And that's called a transversal. And basically, if you remember from high school geometry, or maybe even 7th or 8th grade, alternate interior angles, which would be this angle and this angle. So they're on alternate sides. Let's label those with some black lines. This angle here and this angle here. They're equal because they're on alternate sides of the transversal. And so that means that this angle here is 50. That means this angle here is also 50. And our entire angle is 80. So we can say, well, this angle down here is 30 degrees. And we really don't need the 30, but we do need this angle over here, angle B. So we have angle A is 65, angle C is 30. So 180 minus 65 minus 30 gives us our angle B, which we would figure out is 85 degrees. So angle B is 85 degrees. So now we can use the law of sines. So we've got, let's get rid of some of this. A over the sine of A, because we know angle A, we're looking for side A, is equal to B, because we know side B, and we know angle B over the sine of B. So A over the sine of 65 equals 10 over the sine of 85. So using, again, our cross multiplication, A is equal to 10 times the sine of 65 over the sine of 85. And again, we're multiplying going diagonally, the values that we know, and then we're dividing by the remaining value. And if we simplify that, then we get a value of 9.1 miles. Okay? So let's think about this. Again, let me just point out, you can double check this, sort of, at least to see if it makes sense. Angle B was 85 degrees and the opposite side was 10. Angle A is 65 degrees, the opposite side is 9.1, which is less than 10 because angle A is less than angle B. So yes, that makes sense. It needs to be less than 10 because of the measure of the angles. So the distance from the boat now to the lighthouse is 9.1 miles. All right, so that's all of section 1. Let me just point out there are 2 separate homework assignments. The first homework assignment is all just equations and calculations. The second homework assignment for 7.1 is the word problems like the 2 we've just done. So make sure you realize that both of them are due together. I just separated them because sometimes you spend more time and maybe a class wouldn't get them all finished in one class time. But you guys will. So happy watching. Don't forget office hours if you need any help. And we will see you soon for section 2.